sending it to another device, then you should be thinking more of MQTT. Because that is a protocol designed purposely for IoT stuff. Don't use HTTP. You have to kind of write several codes to handle several things. Which is something it's doable, just that. And the runtime something to be another problem for you. But HTTP kind of requires certain network. Like your network strength must be in this certain limit before you can send a request over. And the next one is this one. You have the big robot computer. So for that one, this is the receiver, this is the gimbal. Hi John. This is the power bank. In the slide I put on the things there, the power bank, the Raspberry Pi. The Raspberry Pi is running Raspbian OS. And Raspbian OS is a Linux-based something. So again, servers are all running Linux. Robots are all running Linux. So if you are somebody that say don't like Linux, see how the future is going, you should start liking it. Anyway, so these are the 12 cells. These are the 12 cells. So somebody will ask me that, what do you have power bank and another battery? So the power bank is powering the Raspberry Pi separate. The 12 cells at the bottom are powering the Arduino. Because Arduino is the one controlling all these 4 ties. And this thing, those of you carry it, you know that it's heavy. So all the work is on this. But all the thinking is on this. But the thinking doesn't require too much in this case. So we are only using this power. And you can see the Arduino is connected into the Raspberry Pi. So it's still using the serial communication. So the Raspberry Pi will receive the command from the joystick using the Pygame library. So Pygame library can read the joystick commands and interpret them. So when I get the interpretation, I now use it to send serial data to the Arduino, which then informs the Arduino to move in the direction you are moving your joystick. So it's just as simple as that. And there's another board on top of the Arduino. That's the motor driver. It's called Adafruit motor driver chip. So that one you can plug directly into your Arduino board. And once you power the Arduino with 12 volts, that 12 volts will be available to the motor driver shell, which is now used to control all these ties, including this. So the purpose of this is for a camera. So at the long run, we are trying to mount a camera on this. And this time, you're not going to use a sensor where this will just be going around looking for space. So we actually want to put a camera and deploy another AI on this so that it can be able to kind of navigate on its own, detecting path, employing its own path, detecting objects and navigating through them using artificial intelligence and computer vision. So that's why we want this. Apparently it's not selling anything, but that's the purpose of this in the future. So this one can go up, down for the camera to see up and down before it can move left and right. So for this one to the demo, first we power this one first. The brain must come on first. We power the body first before the brain. We're chasing it. So we power the brain first, then we power the body. So after that, we just on the joystick. Why is it not moving yet? So when we're programming this, I know one of my guys, Solomon, he really helped me program most of this robot. The way we're programming it, we try to kind of implement some kind of gear system. So when the machine boosts, the robot boosts up, it's in neutral state, it's not in any gear. So the buttons now, this one is first, second, third, fourth. And the thing is that, you see motors, they have something called arc revolution per minute. Now, the motor drivers, together with the motor type they are using, they have different outputs. So the DC motor we are using to drive the tires, these tires are all connected with the DC motor. And the highest revolution is 200. So we now decided that we will kind of separate it into four categories. So if you press this button, it's going to give all the motors 50 RPM. So it will only revolve 50 times a minute. If you press this button, it will go 100 times a minute. If you press this 150, 200. So that is the highest speed is now 200 revolutions per minute. So we are using that like gear system. And we are also using this for maybe brake. You can remove it from gear. So you can use this for brake and you can use this to remove from gear. This is light. This is backlight. This is buzzer working. So the LEDs, that's what we use them for. So if I put this in first gear, very soon, second gear, that's 100 revolution per minute. This is 10. This is 150 revolution per minute. And this is the highest. 400 revolution per minute. So that's now on to maybe after the program. Those of you who wants to play with it, you can play with it. That is I really guys would like to play
You do not explain how they turn. How you turn it. You do not explain how to turn it.
So there's a question somebody's asking me. These things are all rigid, like fixed. So how is it able to turn? So there's a mechanism for that. When two tires are turning forward and two are going backwards, what it will do is that it's going to turn at the same point. It's going to turn in a circular direction. So that's what you are doing. So if you want to turn right, then we'll let the left tires turn forward fast. Then we'll let the right tires go reverse. So if the two right tires are going reverse and the two left tires are going forward, to force the robot to come into the right direction, to turn toward the right direction, and vice versa, we'll let it go. But if you keep it still at one place, it will be going around like that.
Thank you.
So after the listening, so the main project we went on for this is year is this. There's the hand machine cutting down this station. So we have our soap, the water, the tubes, and we have our LED. The LED actually estimates it as fitted. So there's the camera. We have the sensor, also the sensor. We have Arduino, we have two relays. We have a breadboard. We have two pumps inside each of the containers. Those are submersive pumps. And during this, we learned another important lesson too. Because in fluids, not fluids or in liquids in particular, they add a serious pressure downwards. So if there's any pump that you want to use, you need a lot of pressure to pull out the liquid into the pump first before you can use the pump, before the pump can now give you whatever at the other end. So because of that, we know that every liquid can have a serious downwards pressure. So when you mount the pumps, we actually experimented mounting the pump upside and using two tips, one for inlet and one for outlet. I realized that when we power the pump will turn and turn. It's not able to absorb, like to load the water into itself before sending it out. So we realized that when we rather mount it in, the downward pressure of the water on the pump is causing a lot of water to rather rush into the pump. So with that little, once you just on the pump, it's able to pump the water easily. And the other thing we also learned, that one, just this morning, when we were mounting the thing was that when we keep this at a lower, so if this is lower than this, detected by hand. So when this is lower than this, if the tubes are lower than this, what's happening is the force. So when the pump starts pumping, it causes that kind of this continuous force to always be pulling the water out. The same idea they used to remove petrol from car to gallon. When you see for some time and you now put it, the force will continue like that in the water flow. And that's because wherever the container that's taking the thing is, it must be below the one. So the same thing, so we're facing that issue. So we have to kind of let this be up higher, so that when the pump cuts off power and stop pumping, the force will drop and the water will not continue flowing. So typically that's everything. So we leverage on the distance, so the commuter machine. So that's what is detecting my pump. So when it's detecting my pump, Arduino is receiving that a pump is detected. But why is it not pumping the water? There's something that we learned when we were building this. You see cameras, when you are far away, you are small. When you are closer, you are big. And in our system, we built it to kind of leverage on using the bounding boxes around the detected object to calculate the parameter. So if somebody brings the hand this and is detected and calculates the parameter around and give me water, that hand is far away from camera. What if the hand is big because it's far away? Camera says it's small. Then the water line will give me and the soap will be small. And if somebody's hand is small and the person brings it here and it's detected, it will give the person plenty water, plenty soup. So in order to avoid that, you want to kind of limit them within a range. So you can only bring your hand within a range. So whether your hand is big, small, in that range you can rate well, and whatever parameter we get will be like the accurate one. So that's why we introduced this, the ultrasonic sensor. So the ultrasonic sensor doesn't work until a hand is detected. So when a hand is detected, Arduino Python machine learning model is communicating with the Arduino, sending the parameter to the Arduino. But when Arduino detects the parameter now, it reads the parameter. It's not going to read the level that the hand is. But the hand is too low. It's not in the range for it to pump water. So it's not minding it. So until your hand reaches that range, then that's when soap and water comes. And this setup, you can actually from it unless you bring it test a hand. So if we have a flat object or something else that is not a hand, so you can even cover the sensor until the model sees a hand, and the hand is within this range. The range that is the one we defined before. So in this our setup, whatever, even if things are passing in front of this, and the thing doesn't have human hand, this will be no mind it. And also when it gets a hand, like I said, the bounding box, the parameter around it is all we use to calculate it. So smaller hand, smaller parameter, big hand, big parameter, big water, big soup, small hand, small water, small soup. So this way it cuts down cost, and companies who wants to kind of do these things can save a lot of money in the way. So that's
we have all enjoyed the day as we have seen through a lot of innovative ideas that are lost. You go again the same way. Okay, after we have closed, everybody is permitted to make use of all of the deals, have a feel of business. This one. We would like to take a word from Dr. Moses, who is here with us. As we have seen the 9th demo, we want to hear from Dr. Moses. Dr. Moses.
Thank you very much. I'm actually excited. This is a wonderful exhibition. I must say that if up to half of my students I mean, I will just see my makeup on the lecture. Beyond that, I wish to thank Franklin and the team. You're actually doing wonderful thing. My prayer is that whatever they're doing now will not die soon, but it will grow. Such that a point will come where those who are within the Microsoft lab, the tech innovators, and all other similar, like-minded campus can come together and organize a serious exhibition where people from outside, industry players, can be invited. So they'll come, we exhibit what they have. And then that side, once that is done, and then you are able to showcase your work, it goes out online. I mean, there are a lot of funding opportunities out there. But all that they need is something to demonstrate that indeed, if they give you $5, you use that $5 to do something meaningful. Not just meaningful, but something that's of impact on society. If they give you $1,000, you'll be able to use it to do something. Is that right? There are some of these days, you don't start with big money. You start, you can go in and when the competition is like, they give $5,000. You come and use that, do something, sell it out. The next one, you keep building and people realize, I mean, the inflows will just come. People will not even be looking for you. Is that, that money is there, it's out there. But how to get it? So I will actually encourage that you set up. I mean, we are always available to you that supporting them. Provided you are serious. As I'm sitting here, I told you I'm supposed to be almost 2:30. I'm supposed to be in another meeting. Is that right? So if I hadn't more or less had a serious discussion with them and I know what they are doing, I won't be here. Is that right? I had to leave. I don't think all important things and then rush on this just to see and take part in what's on this. So I encourage all of you. As I always say, to be in the area of computing, just like learning motor vehicle. You can read and get your A's, but what you can combine your mind and your hands to do is what defines you as a computer. Whether you study security, data science, network science, computer science, IT, my first encounter. No matter where you find yourself, is that right? You must be able to use your hands. And I've been mentioning this in class. I know a lot of products. You see them walking around here in Ghana. If you're on campus here, but they actually pay the dollars. Is that right? They are not into Bitcoin mining and those sort of things. They work remotely. But if they're able to demonstrate that they have the ability to contribute, once they are given the opportunity and they are able to deliver, I mean, they will just hook you up. Is that right? If you are able to consistently deliver, then you don't even need to leave your bedroom. You only pray that your mother will not come back in your house. Smoking weed or doing other things. Is that right? So on that note, I will leave it here. And encourage the equally state that. Particularly the Tech Innovators Club. I mean, we'll see what we can do to get it registered. Is that right? First within the university, if the need be, we can register it on outside the campus. So at least we'll have that certificate to be able to support and the other funding to be able to grow their business. So on that note, I wish you well, and I pray that all that you are doing will grow and grow forward.
So, as it is, he has said what you all need to know. And as the day we are celebrating is open source, so as the campus setting or Arduino CKT-UTAS is also open source. It's open to everybody to join. You can join us at any time. We always meet every Saturday at the hour of 4:30 to 6:30. And we also try to learn a whole lot about the sentence. It all starts like training yourself like a child to where he is. So that is the same kind of idea we are all also trying to take up from it. So let's pick or grab this opportunity before we leave the walls of CKT and be paying $2,000, 200 cedis to learn some of these things. They are free here. Let's acquire it free. So we are open for everybody to join, participate and come and join us on every Saturday as we learn about the world of embedded systems. Let's all try to be creative and let's all contribute a quota to the tech industry. Thank you very much for coming for today's session.
Then after that, you also want to play around with
But I look my
So you take a good picture, then after that,
I get FIFA for them.
so let's arrange ourselves. Where are my media men? Media men. Mindful of the point. Let's take a very nice picture.